Thank you. Hello everybody. My name is Ville Junttila and I'm from Finnish Environment Institute. And I'm going to talk you a little bit about pharmaceuticals and our research project which we are doing together with our Estonian colleagues. So, as we all very well know, the pharmaceuticals are very crucial for well-being of our societies, but those beneficial properties can also turn harmful when these compounds are entered to the environment. And these pharmaceuticals, they are designed to have an effect, so this makes them biologically very active substances. And although most of pharmaceuticals are not most persistent compounds, their flow from the communities to the environment is typically almost continuous, which leads to their constant presence in the environment, making them so-called pseudopops, or persistent organic pollutants. And pharmaceuticals have also been noted to accumulate in the food chain, which extends their effects beyond aquatic organisms. And it is also widely acknowledged that more information on the occurrence of pharmaceuticals and the risks they pose is needed in the Baltic Sea region. And this is why the updated HELCOM action plan includes 3 actions specifically addressing pharmaceuticals. And one of those is to improve the knowledge base about occurrence and effects of the pharmaceuticals and ensure this information for the expert community by 2025. Well, how much information do we then have about pharmaceuticals in the Baltic Sea? For this presentation, I conducted a quick literature review to assess the quantity of scientific publications on the occurrence of pharmaceuticals in the Baltic Sea. Well, this is not the complete picture, but the left side map shows that indeed studies have been conducted, and especially in the southern Baltic Sea near the coasts of Poland and Germany. And in addition, more comprehensive surveys covering almost entire Baltic Sea have been done, as shown in the right maps. And apart from this, there is also some grey literature, such as governmental reports and other non-peer-reviewed studies. And all these studies indicate that the presence of pharmaceuticals in the Baltic Sea environment is very extensive. And especially near cities, certain pharmaceuticals can pose risks to the well-being of marine environment. Well, although some of these studies have collected a significant number of samples, the number of sampling events has generally been small. So in other words, these results only provide information on momentary concentration levels of substances that happen to be present in the water at the time of the sampling. So to obtain a comprehensive picture of prevailing concentrations with crab samples, a large number of samples usually need to be taken. If we want to, for example, assess the average concentrations levels over a year, around 8 to 10 samples usually per site needs to be taken. And this high number of samples, in case of hazardous substances, 10 samples per site is considered high number of samples. So this means also increasing costs. And in case of pharmaceuticals, this can pose challenges as their analysis is usually very expensive. And also the one drawback of crab samples is also that the environmental concentrations may be so low that analytical methods cannot detect or quantify them, and yet these concentrations can still be significant for the organisms that are exposed to pharmaceuticals. So one solution for this problem could be the use of passive samplers. And these passive samplers are devices containing collecting medium, and this medium binds substances from the surrounding water, which can then be analyzed in the laboratory. And based on the amount of substances that are accumulated in the samples, the average diluted concentrations in the water during the deployment time can be estimated. And with sufficiently long deployment time, even very low concentrations can be detected, and additionally those substances that may not be consistently present in the water can be also identified. These samples have been designed for various types of substance groups, such as for pharmaceuticals, but also for PFAS, pesticides, metals, etc. So in our study, we are deploying these passive samples along the coasts of Helsinki and Tallinn, as well as in the open sea of the Gulf of Finland. And this sampling is conducted 3 times for 3 to 4 weeks each time, which provides a total of 2 to 3 months of data collection on pharmaceuticals in marine waters. These samplings are carried out in the fall, spring and summer to account the variation in pharmaceutical use during different seasons, and also to account the changes in environmental conditions. For instance, allergy medications are more commonly used in the summer, and thus their concentrations in the environment have also noted to be higher during that time. And in summer, the conditions are usually more favorable for biodegradation of pharmaceuticals compared to fall or winter. So we have chosen 3 sampling sites in both countries, and also 1 deployment will be conducted somewhere in the middle part of the Gulf of Finland. So our study is one example how these resource vessels can be used in transnational monitoring studies. And we are studying locations that should not experience direct pharmaceutical loading, as well as clearly loaded or diffusely loaded areas. So in this way, we can see if these substances can be found from areas where you would not expect to find them, and we can estimate if other pollution sources than wastewater treatment plants exists. And finally, our project aims, of course, to provide information on the occurrence of pharmaceuticals and to support the state assessments of the Gulf of Finland and the full Baltic Sea. So this is direct input to the Baltic Sea Action Plan. And we also provide experience and guidance in the use of passive samples in future monitoring studies, so these could be utilized more widely. And of course, one main goal is to foster collaboration between Finnish and Estonian researchers, and that's what we have been doing here during this great event. So we will continue our research, and hopefully an opportunity will arise for us to present our actual results in the fall of next year. So thank you.
Thank you, Ville. Any questions from the audience? I have at least one question. What are these pharmaceuticals? Where they come to the sea? What are these substances which are called pharmaceuticals?
Well, most of them comes from our everyday use, of course, via wastewater treatment plants, but also agriculture, fish farming, our leisure housings are sources for these compounds.
Okay, any more questions? Yeah, here, please.
Thank you for the presentation. Actually, I mean, maybe a couple of years ago, I had experience with this passive sampler. We use this to measure some pharmaceuticals in surface water in Estonia as well. Well, I just want to ask, do you experience any loss of your sampler during this installation in open sea, and how do you handle that?
Did you ask that, did we lost
sampler? Did you lose any of your sampler?
We are doing our first sampling round. Currently, we have collected our Finnish samples and the Estonian samples out in the water. We missed one point. I don't know why. Maybe it was due to lack of my knot-making skills. Maybe it was pirates, but anyway, we lost one. And this is one drawback with these passive samplers, that if you lose one, then you lose lots amount of work and information. And these are maybe a little bit more expensive to take these samples compared to crab samples, but yeah. Please, can you repeat?
In which water depths those samplers are?
We are trying to get them at the middle depth, so at the coast, if typically near the Helsinki, the depth is something 8 to 10 meters, so middle depth.
I apologize if I just missed something, but what's the output? Is it just presence absence? Is it some integrated value, presumably not concentration because it can't keep going, but what's the output units, I guess?
Yeah, based on the amount that is accumulated to the passive samplers, we can estimate that what has been the average concentration in the water during the passive sampling time. And this can be done for some compounds. For some compounds, we need more information to estimate the accumulation rates, but for some compounds, this information already exists, and we can estimate the average concentrations. And then compare to them to the harmful concentration levels to do the risk estimations.
If you have a real problem with losing the samplers in the buoys, I suggest you use a benthic release system and rig the whole thing so that the sampler and the buoys are at the depth of 10 meters or wherever we want to put them. And then once you want to retrieve them, you go out there and put out the hydroacoustic release, and they come to the surface. And for this we can use Aranda, we can deploy those things for you, and we can collect them.
Okay, sounds good.
Any more questions? Okay, here.
Yeah, hello. Thank you for the great presentation. I would like to ask if these pharmaceuticals, they are accumulating in the ecosystems and possibly very negative effects will occur. What kind of strategies of policy implementations of such, do you know, are there now implementing or?
Well, that's a little bit difficult question because, of course, we can't go to tell people that you should stop using pharmaceuticals, medications. But I guess that improving the wastewater treatment techniques will be one solution. It will be required in the future to clean more micro pollutants from the wastewater. And also we can educate people that please return the unused pharmaceuticals to the pharmacies. Do not throw them to the waste or flush them in the toilets and that kind of thing.
Thank you.
Yeah, Jukka.
To answer your question, there is now Water Framework Directive. The EU priority substances are now under revision, and there are candidates, new substance candidates to be proposed by Commission, and they include several pharmaceuticals. And if this directive proposal will be approved, there will be binding maximum concentrations of these pharmaceuticals allowed in surface water. And by that way, it improves its possibility that the emissions has to be decreased for these pharmaceuticals. But it's still proposal, but looks like these pharmaceuticals will be included to the directive.
Okay. I don't see any more hands, so thank you, Ville, very much.
Thank you.
For this interesting